So today we have Sonny with us. Sonny was recently ranked in the top 10 data scientists in India 2020 by Analytics India magazine. He has been a serial hackathon winner, winning over 20 plus hackathons. He has an MBA from IIM Indore and an engineering degree from Indian Institute of Science and Technology, Shibpur, West Bengal, which was formerly called BESU. He has over a decade of work experience in the IT industry. Currently, he's a principal data scientist at Microland. We will deep dive in understanding his journey today and get insights from him on data science as a career. Welcome, Sonny. It's great to have you with us.
Thanks, Shiga. My pleasure.
Great. You happen to be alumni of IIM Indore, where I also graduated in the first batch. So it's good to connect with you as a fellow alumni, besides the fact that we're going to be talking about data science today as a career. So good to see that you're going places. Was wonderful to see your ranking in the top 10 data scientists in India. That is absolutely fantastic. So,
thank you. Thank you for the kind words. Yeah.
Yeah. So, Sonny, actually, that's one of the things that, sort of defines you today. You've had a decade-long career. You're ranked in the top 10 in your field. Tell me, how did you start your career and how did you reach this top 10 list in your profession?
Yeah, I think, let me very quickly summarize, the entire journey. After my engineering, I joined TCS and I was part of the team which was building the data warehouse for a large bank, right? And that's where we got to, that was our first meeting with data in terms of, how data looks like and the engineering part of stuff. The initial few years of my career were all around data engineering, in building systems, large scale processing, things like that, right? And it was around 2012-13 when analytics as a terminology was kind of getting up in the industry, right? And people were talking, in India, it was still a very new age thing, but in the US, it was kind of already picked up and people kind of knew about this thing, right? And around that time, I was also planning for my MBA, and that's when I joined IIM Indore to pursue my MBA, right? And our the MBA program at IIM Indore was also having a specific focus on analytics, which was again one more reason for me to go that path, right? So the MBA that I did was, again, it's a horizontal education, right? It spans across many things, but my focus towards analytics was always there. And one of the initial things that got me kicked into this was that initial case study that we heard about a company called Target, which there was a news saying that Target was able to identify that a girl was pregnant before the family knew about it, right? Now that was an amazing case of how data could be used. By the way, that also breaches privacy. That's a different stuff. But then it was an example of how data could go steps beyond what we could do without leveraging data. And that's when all this this desire to get deep into data and the desire to get deep in analytics is something that kind of pushed me further. Because of the initial years of my career, I had a fair bit of exposure to programming and coding and things like that. So it was not something difficult for me in terms to get into this space, right? And after joining Microland, we were working on various projects around this space. And then the journey kind of it kind of started, and it was going full blown. Now, one of the major things for this was competitions happening in the space, right? The space is blown up, and we see everybody coming, throwing a problem statement as a competition, where you get to see firsthand data of a domain that you probably don't have access to, right? That way, you kind of acquire a lot of domain knowledge about various things. And that process continued, and in that process, a lot of competitions and things like that, and the desire to learn more, learn new things, kept on going. And I think that's all which has been, that's the reason which has been for where all this, this top 10 thing that you heard about. It's all a culmination of all those steps taken over the last few years.
All right. So That was enlightening. Now, you mentioned that there are a lot of competitions and this place has blown up in terms of people competing against each other to be the top data scientists. Uh, Besides the top 10 ranking, which is with you, I read something about a global competition called Code Gladiators, which I think you came number one, I think, as a team out of 2,200,000 people that participated. Is that right? So tell me more about this. Not only in 2018, but I think in 2017 also, this competition happened. And besides this, you have won 20 plus hackathons. So what is this all about, and how did you? What was this competition about? What did you do there?
Oh yeah, so yeah, a lot of competitions happened over the last few years, and specifically TechGig Code Gladiator was a big thing. The reason was, TechGig does that as a very large scale. In fact, I think the 2017 edition got into the Guinness Book of World Record for being the largest offline competition of that scale, right? So in both the years, I mean, I was accompanied by a friend of mine, and we participated as a team. I think the first one was a problem statement around clickstream fraud detection. So it was run by Times Internet, where they had all the data about all the ad campaigns that they run across all their publisher networks. And as we know that people get paid when they click on ads, right? So there's a lot of campaigns which attract lots of robo clicks to generate false impressions and false revenue, which again basically means a loss of money and reputation for the advertiser, right? So they had this huge amount of data. In fact, they gave us data about, I think, just a week's. Yeah, they gave us a week's data, which is almost like, I think, only for a couple of websites, which was, I think, 20-30 GB, and which was actually very small because most participants would not be able to handle terabytes of data on their on the infrastructure that people would have access to. So we had that 20-30 GB of data, and the problem statement was simple, right? It's saying that this is the data of all the clicks that happened on my website over the last 1 week, and I have some way to detect which one are the genuine clicks and which one are the fraud clicks, right? Use this data to build machine learning models which can tell you, okay, this click is genuine, so that you can in future, without human beings doing that validation, a computer program can automatically flag a click being valid or not valid, and then that can go back into their process of charging the advertiser or not, right? So that was a problem statement which given to us, and I mean, it was a 24-hour hackathon, and we were sitting all the night there, analyzing the data, visualizing it from different perspectives, and trying to figure out what are the different patterns, what are the parameters that could help a computer detect that it's a fraud, right? For example, things like what is the interval in which the clicks are coming from a specific IP address, right, or from a specific browser. What rate people are clicking, or is there a specific consistent rate? Like, for example, let's say you get a click every 5 seconds, which is not human like, it's like more computer program, right? So these are things that you have to think about, and we were doing all of that, and and our model was the best one, and we finally presented that solution, and it was a large competition. Finally we won that competition, right? And in the other edition, the problem statements, it was two different competition. One was around stock market prediction, where we have to predict future prices of stocks on the US stock exchange. And the other one was mutual fund allocation, where by using mutual fund data, could an asset allocation company figure out which of its investors are going to sell off their mutual funds, right? Now, if you see the linkage between all of them, they're completely different problem statements coming from different industries, right? But the way to solve them is fundamentally similar. With very little bit of domain knowledge that I and my friend had, we were able to attack all of them, right? And that's why data science, and you'll hear about all of these terms, cutting across industries, right? You don't need to be extremely heavy on the domain side to be able to excel. And I think we'll talk more as we go ahead, right? And I think all the other 20 competitions are around this. The secret component of winning a competition, I think, is how good you understand the problem, how quickly can you prototype different types of ideas, and how quickly can you build something which is sellable, which can be convinced, which someone can consume, and it is productionizable, right? So I think these are the components which are very important when you take part in competitions and try to replicate a real world use case.
Right, that was pretty helpful to understand these competitions. Now, so competitions are fun. Daily, do you enjoy your job as much daily, or is a data scientist job not so much fun? I mean, can you? I mean, it sounds boring. It sounds a little dry, numbers, I guess. But I think different strokes for different people. So, tell me about your job. What does your day look like? If somebody is evaluating this career, I think it would help them understand what does a data scientist do? What happens in the 8 hours that you're in office?
Okay, so see okay. Let's have a very simple definition of what a data scientist does or is supposed to do, right? So a data scientist is supposed to fundamentally solve problems, solve business problems, which were either solved previously and you can solve it in a better way now, okay? Or there were no solutions for them, so you're now bringing new solutions which will help you edge the new offerings and products to your customers, right? And then finally, you're able to bring value for the organization, right? That's what data scientists have to do, right? Now, that's still very high level. Now, if you break down, you finally have a set of business problems at your disposal, right? And you start breaking them down into smaller, tangible, smaller problems, right? And then try to evaluate through the lens of a data scientist as to whether, what is the right way to solve the problem. One of the very important, work of a data scientist is to actually figure out when not to apply data science to. You don't have to apply data science to every problem statement. There are far easier ways to solve problems, and you only want to bring in the complexity of things like this when they actually demand, right? So when not to apply data science is a very important thing, and when to apply, how to apply, right? What is the way to apply? Given a problem statement, you have to understand the boundaries of its application. You have to visualize how will you productionize the solution, because if you build something which cannot be productionized, right, then it is not useful, right? So a data scientist has to think on that execution part of the things, right? For example, if you're solving a problem where the time window is very limited, right? You have a very small amount of time when you have to do your analysis and present the results. For example, let's say if you were predicting whether a patient is going to have a heart attack by monitoring all the telemetry that you can get from its health statistics, you have a very small amount of time, right? If you predict that is going to have a heart attack after an hour after he already had, the information that you're giving it's of no value, right? You have to be maybe as soon as if you tell it before it happens, then only people can take an action, right? So in that case, the way you solve the problem is going to be different. Probably you will take you have a fight between latency and accuracy, things like this, right? So a data scientist's work is fundamentally around defining problems, or you already have problems defined. You break them down into tangible set of problems, understand which set of problems can be solved with data science, and once you've identified them, build an hypothesis around how will you solve that problem, what data you will need, because in real world, nobody gives you the data that you would actually need. You have to understand the domain and figure out what data would be needed for that, and then find a way to acquire that data. Once you have acquired, you analyze the data, you act like a data analyst, going through the data, trying to validate what you've hypothesized, whether it's correct or not. And once you have a decent idea on all the insights that you've generated, you use technology and tools and frameworks where you can build a prototype, and then you can sell it to the stakeholders and see what benefits it can bring to the organization. So typical days all around this. In my organization, almost every day we have a new problem coming from a client. There's a business problem given to us. For example, a customer says, I am getting $1 million of cloud consumption bill. What can you do to reduce that bill by, let's say, 30%? Right? That's a high-level problem statement. We chip in, understand, we break down the problem into smaller sets, see what data is accessible and available, and then get to the point where we can build a POC and show them, hey, by using this, you'll probably reduce your bill by 20% the first month, and then 30% the next month, and this is how it will work. And then once that POC is built, we kind of productionize that. And there's a lot of engineering around how we productionize that. But it's actually fancy. It's actually very interesting, because every day you end up doing something different. While your approach and strategy might be similar, but it's completely different. So it's not monotonous, and it's very challenging.
Right. So does this involve team management? Like somebody who's maybe just evaluating this as a career, what are the kind of things that you'll be doing in a day? Like you come in at 8 o'clock, do you start with a morning meeting with your team? or do you just head into work? So is it more individual work, or does it involve teamwork? Who do you report to? So just maybe break down your day in terms of hours and help somebody understand what does a day for a data scientist look like?
Yeah, so it depends on what career stage you are in. But for someone who is in the entry level and is recently graduated and spent a couple of years in this field, he would be, probably working in a small group of people. Usually, data science teams are not large teams. They're very different from software engineering teams where you have a large floor of people doing a lot of stuff. Data science team is going to be a very small team. You will have a handful of data engineers, handful of data scientists, and a data analyst guys. They form a team, and there's someone who kind of understands all of them, who is kind of is a bridge between the technology and the business team, who gets the requirement, tries to frame the problem statement, and then with that team they kind of solve that problem. So if you are a data analyst, you would be probably spending most of your time where you have got a defined problem statement and a data set, and your work is to find out insights out of this. If you are a senior guy, then you would be spending time ideating on various solutions. So it could be more like a teamwork where you guys will meet together and think on various solutions. And if you're at the senior level, then you will spend most of your time on communicating the results, finding the next use case, and taking the story out. But no matter which stage you are in, you'll always have a distribution of your work between brainstorming sessions, which is about teamwork and ideating how to do things, programming and code writing stuff. This is piece of this time. This is the work that you actually do individually, where you have some data and you are analyzing, writing code, doing things like that. And the last part is how do you build a prototype and then communicate the value and show it to someone else, right? As you go up, that percentage of work becomes more, and your initial brainstorming work becomes more. Maybe the coding slightly reduces, but in the initial days, the coding part and the tech part of the work might be more. And depending on whether you are a data engineer or a data analyst, depending on that also, that percentage kind of changes.
All right. And is it any time when you become a senior person in your organization, does engaging with the client directly, does that come into your purview, or is that something that's managed by the sales?
No. So this is very important. This is a role where at some point of time, you have to become a client facing person. Okay. The sales guys are the person who have foot in the door of the customer. So they probably can pitch in the solution and they get the customers buy-in, saying that, hey, we have something we want to hear. And then you are the tech guy who gets into this. So when you have acquired, let's say 5-6 years of experience in the industry, you are expected to have good communication skills. You are expected to talk with your clients, talk in both the technology language, which is of course needed, at the same time a non-technology language also, depending on who you're talking to. If you're talking with a non-business, non-tech guy, a completely business guy, if you tell him stories about the fancy deep learning model that you're running, probably it's not going to sell. But then if you talk about the business KPIs that he understands and how the technology solution is going to address that, it's going to be very useful. So after you have like 5-6 years of experience, you will be doing a lot of client engagement, and it's going to be extremely driven by how good communicator you are and how good storytelling can you do.
All right. So one of the things that you talked about was the difference between, I think maybe you mentioned both. You talked about data science and data analysis, right? So there is a job called a data scientist and there is a job called a data analyst. How are these different? For me, I've always thought that they're almost the same thing. I think most of our viewers would have a similar confusion. So tell us about the differences between these two.
Yeah, I mean, data scientists, data analysts, and data engineers. These are the three broad categories of roles in terms of in the job market that you will probably see. And it's important to understand the difference. But before that, let's understand the similarity between them. What is common in all of them? You have math common. So you need to understand a little bit of math, right? The degree of understanding will differ in all of them, but a little bit of math is very important, right? How do you understand, how to slice and dice the data? How do you see the data is something that you have to grow naturally, which is very important, right? And the third thing is you need to have an access to a set of tools and technologies by which you're going to do that work, because you are not going to do everything with pen and paper, right? You will need, maybe you will start with Excel as the tool if you're a data analyst, but with time you will probably go into BI tools for doing that stuff, right? So these are the things which are common. Now let's come to the dissimilarity part of things, right? A data analyst is very focused, I would say, bounded area of work where that person has been given with a defined data set, right, with a high level problem around it, and the person's responsibility is to kind of analyze that data and find insights which can be helpful for the business to take decisions, right? So what it means is majority of the time he's doing analysis of things in the past. He's analyzing data which has been generated to find insights, right? It's not doing anything to do with prediction in the future, right? It's not doing to say, okay, with this data, can I predict tomorrow's value? No, he's not doing that. If he is in a manufacturing company, he might use that to find out what parameters leads to failure, right? But he won't say that I can use this to predict the failure, right? Prediction is not part of this. He's analyzing in past, right? And the second thing is most of what he does is around descriptive study. Now, by descriptive study, we mean about historical study, understanding the trend, understanding the patterns, things like that. So it's a very defined, narrow, objective, and he's actually finding answers to questions which have been already given to that person. The business has defined a set of questions, and all his analysis is around those questions to find answers to it. A data scientist's work is slightly different. His work is to find answers to questions which have not been asked, or answers to questions which don't exist today, or we're not aware about those questions, right? So his work is going to be, while he will be doing what a data analyst is going to do always, that person is going to analyze the data and all of that, but is going to focus more on prescriptive and predictive study and not on the descriptive study only. Descriptive will be done, but predictive and prescriptive is what will happen and what to do to make something happen. These types of ideas are what are going to be fundamentally driving a study. And that means that the tools that you're going to use are going to be different. A data analyst, an entry-level data analyst, starts with Excel and BI tools for most of their work, with a little bit of programming, so that he can quickly iterate and ideate his thinking. But data science will be getting into algorithms and machine learning and prototyping things, which go into the AI space to do futuristic work. That's where data science and data analyst differs. Data engineer are the set of people whose work is to set all of this up, right? Basically, you can think of them as people who are close to software engineering and data science, but they understand the technology landscape on productionizing systems. So once you build your solution, how does it work in the real world? How does it get hosted? Where will it run? How will it get the data? How will it publish its result, right? That piece of thing, and there's a lot of thing around that. It's a very big area of the data engineering part of thing, which we will also do. So I think that's a broad level, idea on what these three terms and three people do.
All right. So now I get a broad overview of the industry and your job. Which are the companies and which are the industries where a data scientist would typically be employed? So which are the hot industries right now for a data scientist?
Okay, so in fact, any industry where there is data, right? Any industry which is generating data and is planning to use that data to increase its competitive edge is an industry where data scientists will be required. By that definition, which means every industry, right? There is no industry which doesn't generate data, and there's no industry that would not want to generate data. If any company in any industry is not leveraging the data that it generates to build a competitive edge, that company will become a history, because that's the only thing data is the new oil that people have to mine to get to the next stage, right? So every industry, literally every industry, healthcare, IT, education, you name it, every industry. And because of the technology proliferation that's happened in the recent years, because of the adoption of internet, by the adoption of B2C companies, and the way people have got access to technologies and solutions, the amount of data that we are generating, right? There are a lot of statistics which say that data generated in the last year is more than the data generated till that point, right? It's exponentially growing, right? So every company, which domain doesn't matter, they are generating huge amount of data, and data analysts and scientists are the people that they would actually end up needing to help them get to this mess and find out that needle in the haystack, which will give them that edge. So it doesn't matter which industry you are from, there are companies who are sitting on a huge amount of data and they would need you.
All right. So I think it's going to be all pervasive eventually, right?
Yeah.
Okay. Now, these are fancy terms, some of them which I keep hearing now, machine learning and artificial intelligence. These are sunrise technologies. how does data science relate to these industries? Is it an entry point to these industries, or what is the relationship between these two?
Okay, so they are not very, very different in terms of they're not completely, different things. They are related, they are similar, just that they have some boundaries which overlap, and we need to have a subtle understanding of what they mean. Let's start with machine learning. Machine learning is a very defined technology stack where the objective is to use historical data to predict the future. Okay, that's it. So if you say if I want to predict what will be the temperature tomorrow, right? It's a use case of machine learning. You have historical data, you want to use that data to predict that. You have historical sales data, you want to use that to project how much would be the sales revenue in the next quarter. Again, the same stuff, right? You have historical data, you predict that. So machine learning is basically a set of algorithms driven technology solution which enables you to mine your historical data, and you use that to predict the future in different ways. For example, there are multiple terms like supervised learning, unsupervised, and reinforcement learning, which basically categorize different types of problems. But the idea is you have historical data, you're using that data to know the future, right? That's what very blunt way of understanding machine learning is. If you take that one step ahead, right, what you're doing that is you're enabling computers to analyze the data and find a way of the future, right? And that's where you step into AI is a much broader umbrella of technology stack which includes machine learning as a subcomponent. And the objective, the whole and sole objective of AI is to make computers think and behave like humans. That's a simple definition, right? Computers are very good at you can program and instruct a computer to do things which you explicitly program, right? If things which are not programmable and which are very easy for humans to do, for example, when you see a dog, you recognize the dog even if you've not seen that variety of dog in past, right? It's very native and natural to humans, but computers are not. Computers have to specifically program saying that if what you're seeing looks like this, then it's a dog, right? Until recently, it was a difficult problem to solve for computers. But now with with deep learning coming in and with various advancements that are happening in the computer vision world, computers can now see through images very easily, right? And they're basically doing what humans are doing, right? The self-driving car and all that, all the new innovations like Alexa and things like that you hear about, right? All of them are using the same sort of technologies, where the whole objective is to make a set of tool behave like humans, think like humans, act like humans, do things which human could do, right? And we are still way back in that journey. We are just scratching there, and the next 10 years you're going to see huge innovation happening on that layer. So that's what, when we say artificial intelligence, we're talking about that set of tools and technologies solving that problem, right? Making computers behave like humans. Data science is an umbrella term which comprises all of them, in some parts an overlapping section, but it also has things like psychology. It also has things like communication, knowledge discovery, right? You might not have a prediction problem or a computer problem here, but you have a knowledge discovery problem, right? Where you want to generate insights which can be used in various ways, right? And that's what data science is all about. When you talk about data science as a terminology, which is a very broad, open-ended, term.
All right. So there was a Tom Cruise movie. I don't know if you remember seeing it. When I was a child, I saw it. Do you remember where this guy is predicting crime? And there's a concept called precognition. And of course, China is experimenting with artificial intelligence, and there is all-pervasive analysis of what people are doing. Do you think this is going to reach a place where, I don't know, I mean, it's been the realm of science fiction. Do you think we'll be able to predict crime eventually? Do you think this is going to get precognitive?
See, I think there are already study happening around this in this stage. See, the problem with things like this is there is this whole idea of data privacy and ethical component of doing things, right? Okay, and the general course of law doesn't allow many things like this, right? And look at the fallacy of things. For example, let's say if you predict a crime is going to happen, right, somehow, and you catch the person before the crime has happened, you kind of make your prediction wrong. You see the circle, right? You do, if your prediction was right, it can actually prove itself wrong, right? And if it was wrong, you don't want to have what that happen, right? Then the usefulness of the prediction is lost, right? So there's a lot of study happening around this, whether law allows this or will allow this. Technically, whether it's possible, I would assume with the enrichment of data that we are seeing today, we are getting monitored from every angle. Google knows more than you know about yourself, right? Think about if government get access to that data in ways they could use it, right? Surveillance cameras are getting put across the entire city, right? In the next few years, you will see every hook and corner having service camera. If you use that data and a lot of things and the historical data that you have, I think it won't be difficult to say you can't do it. I think the bigger question is on the dark side of the adoption, right? How do you consume something like this, and does law do it, right? And is it ethical? That's a big question, right? We can do, is it ethical to do, which is also the biggest question.
Yeah, that's true. That is, I think, the big challenge. I think, and we are going to be dealing with these ethics very soon. Okay, now, good overview of things. I want to understand. Here is a young boy who stepped out of college. All right, he's thinking that data science is something that I want to do. What kind of skills does a person need to enter data science as a field? So this is a three-part question. What are the trainings that are available in India, USA? What is your view on that? Which are the best places to go for training? And which are the best institutes which are giving training right now? Do you have a view on that?
Okay, so for people who want to get into data science, right? I mean, of course, there is some component of data science education which is kind of trainable, right? You can train someone by making him learn set of concepts, right? But there's a large component which is not trainable. It comes from experience, and you grow as you learn, right? So if you're a new guy getting in this industry and you're kind of or maybe someone who has very small number of experience and is trying to get into this industry, what are the expectations from you, right? The first expectation is you have a very good analytical thinking of, your analytical brain can think like an analyst, can think, when any problem statement is given or anything you're discussing, the analytical way of thinking, the logical reasoning stuff, right? The ability to question things, the ability to think beyond what you can see, those characteristics are very important, right? Because if you can't think in that perspective, at some point of time, you will actually not enjoy that, because it was going to be demanding from you. People are going to give you very open-ended problems and expect you to come with solution, right? So thinking analytically, solving problems in that ways, problem solving, as a skill is so important when you want to get into this space, right? The second most important thing is programming knowledge, right? The ability to code, right? I personally do not, do not believe in the fact that a data scientist can be a very great data scientist without knowing anything about coding, right? There are people who have a different school of thought on this, but I think you need to be very good at code. The reason is what you think you have to see in front of yourself, and to see that you have to write code and you have to do it very quickly so that you can see you can validate what you're thinking. And that's an iterative process where you have, let's say, hundreds of ideas, and you want to, in very short span of time, evaluate those hundred of ideas and then get to the next stage. So programming skill is very important. This is an area which is trainable, right? You can join an institute, you can get a mentor who can train you, and you can learn programming and coding to some extent, right? This is a trend which is easy to acquire. And the last most neglected part of data science, data scientist requirement is you should have a very good communication skill, right? You will sooner or later be sitting at a position where you're going to be talking with the consumer of the solution, or the business owners who are going to accept or reject your solution, or people who are going to buy your solution, things like that, right? So if you're not a storyteller, if you're very weak in communications, and you're not able to convey your ideas well, even you might have built a brilliant product or brilliant model, people are not going to accept it, right? So these are qualities that you have to acquire. Some are acquirable, some are not, but over a period of years you need to get to that stage. If you think you can, you should get into this. If you think these are things that you might not do or willing to do, probably that's not the space you want to get into, right? Now, how do you acquire this? The best way today to acquire most of what you need to learn, if you're an entry guy, is through MOOCs. Okay, there are free open courses. The internet is flooded with open free resource. Okay, it's completely free, and even if there is a charge, it will be peanuts for you in the long run. But massive open online courses, it's a way to go. Coursera, Udacity, name you will find hundreds of them. You should take them, see them, analyze them, and apply them. Now, how can you apply if you're not yet somewhere? There are two ways. One is competitions. You should always go and try competitions. There are hundreds of competitions happening around, because competition will teach you a couple of things. One is it will give you a business problem and you will expect you to kind of solve through it. Second thing is you have hundreds of other people doing the same problem statement, so you can form a team, ideate, and learn in that process, and you can share concepts, right? So you're learning that stuff, right? So that's very important thing. And the third thing is, if you can get a way to intern in some place where you can do something like this. If you already have experience, if you can find some place within your organization where you can try and apply what you have learned, because that would be good. Because I've seen many people who have taken see this industry, because of the proliferation of data scientists and the all the marketing and things that's happening. You will have seen that hundreds of organizations are running programs to coach you and train you on that. The biggest problem with most of those programs is they are very wide, and they need to be wide because they want you to learn hundreds of topics, right? So they will teach you chapter 101 of everything, and probably at the end of the course, at the end of the curriculum, you know little bit of many things. But the problem is, you need to go more deep than wide in the industry to be accepted, right? So going that deep to wide is what needs your involvement, right? So you have to find a way. How can you get to the place where you can try hands on and build a profile of work you've done. And if you're doing it on your own, you should use GitHub as your place to showcase your work, so that your GitHub profile shows the kind of work that you've done, and recruiters can actually get a view of what you've done even without you working in a company. People who are in the college, they are still doing this to kind of tell that story. I personally know many people who have taken a 1 year course somewhere, but within 6 months they have lost all the knowledge that they had. What they remember is superficial terminologies, which doesn't help actually, because when recruiters come to you, they expect you to do a little further. It's a kind of chicken egg problem where you need to find a mentor, and if you're new in this industry, or you get lucky where you get recruited by someone and you deep dive into this. But you asked which are the good training institutes. Personally, I've not reviewed the curriculum of any one of them, so I don't think I'm the right person to name anything. But I would suggest, and the people who I've recommended, I've always told them that first go and complete maybe the 30 top free online courses, and after that probably you have learned almost 90% of what you would have learned anywhere else, and see what you can do to apply that.
So now you talked about MOOCs and Coursera, and learning through that. What is the receptivity of HR and your functional managers? Are they open to hiring people who have gone through MOOCs, or do they want a formal degree?
So so the way it is even you have done MOOCs and hundreds of people are doing MOOCs, right? So where is the differentiator? It's very important that you have to be different from someone else, right? So if you have done MOOCs, don't even write in your resume that I have completed course A, course B, course C. Doesn't mean anything. Great that you have done, good that you have done, but what do you do with that knowledge? Did you try to apply that to solve a problem? Today you have lots of data available already. Let's say you have learned about this technique called regression. Regression is basically a numeric prediction. You can predict a number, right? So what could you do? Probably Google some interesting data sets that are available. Kaggle is a place where you get a lot of data sets. Indian government is making a lot of data sets available. Go and grab some data, some interesting problem statement, build a story around it, put it on GitHub, put a link, and then put it on your resume saying that I've worked on 5 different problems. Here's the code, here's the link. I think that's where people appreciate it. Now, how did you do that? You did a bunch of courses because no one was there. So you did a bunch of courses to acquire that knowledge and apply that. So HR and recruitment folks do give importance to the work that you have done as more than a set of courses or certifications that you have done, because the market is flooded. When we open a profile for hiring, we get hundreds of profiles. Everybody has done a course A from Institute ABC or a course from this, so there's no differentiation. We literally can't use that as a hiring filter. The hiring filter then becomes probably things like, do you have a GitHub profile? How many repos do you have? What type of programming language do you know? Did you participate in any competitions? Do you have any prototype of products online? No, we use those as filters rather than any degree or course that we've taken.
All right. So that is going to be helpful to the freshers. Now tell me about people who are going through their career. They might have about 5 to 6 years work experience, and now they are suddenly interested by data science, or they're hearing about how big it's becoming. What kind of profiles can make a jump into data science? Is it open to mid-career professionals? Can you make a switch? And if you can, which domains are the best ones to shift from? I mean, I know somebody who's maybe in marketing might not be able to shift to data science. So which are the allied fields from which somebody can make this jump?
Okay, so first of all, if you, if you are early in your career, it becomes very easy for you to, because you don't have a lot of, people don't treat you with an experience, right? So it's for you a new game, so it's very acceptable and it becomes easy for you. But when you have, let's say somebody has 10 years of experience, 8 years of experience, and that person wants to get into data science, the question is, can he or she do, right? The answer is yes, definitely. Now, the approach to doing that has to be different, right? The first question is, why do you think that you can do it, right? It's not because you want to do it. That's not the answer. Why you think you can do it, right? What is that makes you, what is the competitive edge that you have? Maybe you learned programming in some part of your life and you've given up for the recent years. So probably it won't be very difficult for you to relearn and do that, right? Or maybe you have a very strong analytical capability, so you know how to break down business problems into smaller subsets and do things. So understanding that why is very important, because that helps you kind of structure your thought as to how you will go. The second thing is, it's very, I've seen people who want to do a completely dramatic shift from their domain to data science and leave their domain. They want to completely leave their domain and get onto, get into data science in a complete, which is a currently risky proposition, because then you're kind of not leveraging on what you have learned, right? As I said in the initial discussion, every domain has application of data science. Every domain, you name it, it will be there. You might not be working in a team within an organization which does this, but if you want to get into this and you already have a domain knowledge, don't leave the domain knowledge. Find a way by which you can get to that, talk to the right person, get to that right place where somebody is doing that, or there could be an opportunity to do that, because that will help you leverage your domain knowledge, right? You can always acquire some part of the skills, the gaps that you have, from outside over a period of time, and you have to give it decent time, right? You have to give it 6 months to a year where you do this preparation. You don't leave your job and say, I will take a 1 year course and then I will do this dramatic shift. It doesn't happen. You are on the job. You give that time. You run your midnight oil and you get to that point, and then you start figuring out whether you can apply that. And if you don't have that option, then it becomes slightly difficult on how do you get a champion who is going to allow you to try that, unless you have done something breakthrough which becomes the news and it becomes easy. But for the most people who have already 8-10 years of experience, they can, as I talked about, analytical skills, programming skills, and communication skills, if they are very good in all of this, or they can fill some of this gap quickly and go back to their domain and find a way to champion this there, I think that's the best way to take a leap forward. And then from there, the roads are, once you get into that space and you've spent some year, from there you can always find nearby places to switch and kind of structure it. But it has to be taken in, small steps.
All right. So one thing that you mentioned is that the field is getting a little crowded. You're getting hundreds of CVs for every role that you open up. And so what is the earning potential for somebody who enters data science? And is it getting crowded? So if it is getting crowded, then what is the career path that somebody can expect when they get in? So how much competition does the field now have? So I'm going to repeat that. What is the kind of earning potential for somebody across his career span? Is it too crowded now for a fresh person to look at it? And what's the career path? What is the career like in terms of how many years do you take to reach the top?
So this space is going to blow up in the next few years, okay? And so we're already there. In the next 5-10 years, you're going to see only an increase and uptrend in the demand, in the requirement, right? What we will, well, of course, where the supply is much more than the demand there is, right? Which means that every hiring manager is always going to fight this battle of finding the right quality resource that he or she looks for, right? And that's where all the work that you've done will help you filter yourself into that into that prime spot, so that you get the attention, you get into it. From a If you look from a earning potential, it pays decently. It pays much better than the other comparable jobs that you would have, which your peers would be doing in terms of the same industry, things like that. And an average a fresher, or maybe someone who has around 2 years of experience, would be anything between 15 to 30 lakhs, in India, in a city like Mumbai or Bangalore, right? And this is a large bracket, because it depends on which company you work for, depends on your profile and what you have done. If there is enough evidence that you are better than the other, right? From that perspective, you can always have a higher compensation. And this is growing with time, because we are seeing that the quality people are still limited in terms of the market. The market needs much more. We have a lot of trained people who have done courses and come into the market, but they don't have this demonstration of skill, right? So if you have done that demonstration, it becomes very, very useful for you. You can leapfrog them. But on an average, the numbers are higher than the industry peers around software engineering and software development that we typically see. From a career path, it follows a similar career path like the other IT tracks that we have, where over a few years or a couple of years, your role changes, and the distribution of the type of work that you do changes, from how much of programming do you do, then how much of storytelling do you do, and analysis, things like that, right? And I think with time we will see that this is going to be more competitive and more demanding, and you have to be always ahead of the curve by reading about the latest development. This is a space where every fortnight a new open source tool or a new technology solution is coming up. So if you wake up, let's say after 6 months, you're completely outdated and nobody wants you. So every day you have to find it, you have to allocate at least 10-20 hours a week to read about what is happening in the industry, about the new things, read and train and relearn, and you have to do that. Otherwise, you will be kicked out of this market. It is extremely competitive and very, very fast moving. So those are the things. And if you do that well, I think there is nothing that stops you from, going ahead in the space. And as we see today, the most companies' leadership is shifting from a pure finance or a marketing driver to a technology driver. So what you will see in the next generation of the companies, all their CEOs will be tech guys who have done tech roles, and not maybe finance head or marketing head. That's a shift we are seeing in the industry in terms of the leadership roles also.
So tell me about that. So where does what is the culmination point for a career for a data scientist? So typically, as you said, the marketing guy or maybe the sales guy can aspire to become the CEO, all right? Or, the finance person becomes a CFO. So does this culminate in a CTO job? And is there a way that he can progress further into a CEO profile? You did mention that's possible. Is that commonplace, or is that the exception to the rule?
Okay, so as you get into data science, and you will, as you start getting deeper and deeper, you'll understand that technology understanding is a very, very strong requirement of data science. You might not start with that, and but at some point of time, understanding technology, understanding software development, understanding cloud infrastructure, understanding edge computing, things like that, right? Everything is something that you have to get deeper and deeper. And once you get deeper into there, you're basically rolling into the CTO ladder. Basically, you're kind of racing towards that journey, and that's the logical way to kind of end. But what we are seeing is, and that's a growing trend, is every company is becoming a tech company now. This is a digital era. Today is not the era of just branding only. It's about building the best product out there, right? So that's why if you look by valuation and take the top 10 companies, you'll see only tech companies out there, and the ones which are emerging are also tech companies. That's where what we're seeing is, in the coming years, while we still don't have enough evidence from numbers point of view, but CTO folks are going to be stronger competitor than a non-technology guy for the CEO role, and someone who has done an MBA or has understanding of of business from a completely from a perspective which a completely tech guy might not know, right? Those types of people are going to be extremely at the upper side because they would be at the intersection of both the places, and they would be able to leverage this. And we're going to see. I mean, only the future can tell that, but that's what I am seeing in the industry in terms of how it is going towards.
So that's interesting for me because you're an MBA from IIM Indore and you have a data science background before that. So I guess that kind of clears up where you want your career to eventually head. So now, so tell me, you'd mentioned MBA as something that enables a CTO to maybe become a CEO. So do you think a data scientist needs to get an MBA today? Eventually?
Okay, so yeah, the short answer is no. It's not mandatory. Okay, it's not mandatory that you get an MBA into it, especially when you're entering into this industry. And if you don't, if I was, let's say, in my fourth year, and I have either I can take CAT and get into IIMs, or probably learn coding and crack data science. Probably I should go the second way, right? Because I don't want to miss that. I can do an MBA maybe in future at some point of time, but this is not the wave that I want to lose, right? What MBA does is MBA is a horizontal education, right? It kind of cuts across so many disciplines that every organization has to go through, and people and that's what helped me actually, right? I've always been a tech guy even before I did my MBA, and even after I did my MBA, I was always a tech guy and I'm a tech guy, right? But what helped me was from an MBA point of view is, it kind of teaches you multiple pillars of how a business runs. Because when I was not an MBA, I was kind of, that was a black box for me. I didn't know, what is the way to communicate the value of a company in terms of, right? For me, technology was all that I understood, right? It was a big black box and I had to fill that gap, right? But once I filled that gap, I realized that, I could understand the dynamics behind what is, how a business functions. And then when you are trying to, build technology solutions, you know what the business needs and how the business will use it, right? And that's the biggest sweet spot for you. And that's what has helped me, because I've been always, trying to see things from the lens of the business and also on the technology. It's always fancy to build big tech stuff, but if they are not usable, if there is no business use case, if there is no business value, then it is always a project for you, which you will be there on your resume and you will think good about it, but it will never make money, right? So that business mindset comes from an education like MBA, right? And when do you do in your career depends on where you are, right? It depends on where you are and where you happen to be. But at some point of time, when you have a leadership role, and let's say you're a data scientist, you have 10 years in the industry, and you are great at technology, right? If you can afford to get an MBA, I think it is never going to be, you won't regret it anytime. It will always open your brains in areas that you never thought about or never gave importance to, right? Any new education is always useful, right? But specifically that gives you an edge in terms of when you are getting into your next stage, into the next 10 years of your career, right? And then you leverage the two and you marry the two in the right perfect sense. And I think that's what I also want to do, and I'm also trying. I'm sure many people would be doing that, and that's my suggestion to also people who are evaluating an MBA at some point of time, if they are in that career state.
All right. Now, one thing that you touched upon, I think, and this is going to be my last question. You talked about data science sort of being the power behind. I mean, data science is powering automation, machine learning, all these things. Do you think that eventually automation might actually lead to the demise of data science, the very power that is sort of the steam engine behind this entire field? Or do you think that's an unfounded fear?
Okay, yeah, that's a very interesting question, because there's a lot of marketing content floating around which talks about automation and why an automation can automate everything. So at some point of time, it will automate data science also. So there's no need of this huge proliferation of demand for data science, and what will they do actually, right? Which is actually a marketing content. Actually, it's not true in the pure sense. So if you break down what a data scientist or the team that does is, there's this large component of work that humans do, right? And humans are great at doing, which is knowledge mining, the way to frame a problem, the way to analyze the problem and then generate insights and then define a way to solve it, right? These are things that we do when you're solving a data science problem. And also there are other things which are in the engineering part of stuff, right? When you deploy your data science solution, there's a huge amount of engineering that goes into it, right? That engineering is what is getting automated today. And today we are seeing solutions like AutoML and other products which are trying to make some part of what humans were doing, some mundane parts of what humans were doing, and some automatable parts of what humans were doing is getting automated. So cloud companies like AWS and Azure, GCP, they are trying to automate the way you deploy an end-to-end machine learning solution. So you don't need too many data engineers to do that, that work. Similarly, on the data analyst part, there's a lot of descriptive study which is available out of the box. You upload your data and it gives you, hundreds of insights that you probably want to, you want to look at, right? So some part of that part will get automated. And I think it's in the good interest of data scientists that gets automated, because there's not much of science and human intelligence needed to do that, right? It's all programmable. So let the computers handle what they are great at, right? And data scientists will be back into focus into doing what they are good at, and that is the science cover part of things, which means actual applying the data to solve problems and thinking about what is the right way to solve problems. I think that's what most of the data scientists will be doing in the coming 5 years, when automation has automated the engineering of the deployment and scale and things like that. But it is nowhere going. It is going to be there. It's just that the way people distribute their time is going to change.
All right. So I think that's reassuring for anybody looking at a career in data science.
Sure. Okay.
All right.
Thanks,
Have a
Shikhar.
great day. Thank you. See you. Great
Same
to
to
be
you.
connected
Bye-bye.
again. See you. Bye-bye. Bye.
Sure.
Thanks,
Bye.
Sonny. Bye.